For decades, scientists have been striving to create an aircraft capable of reaching the speed of light. This pursuit aims to answer some of the biggest questions of human existence, including the origins of life and the mysteries of the universe. With NASA's latest light-speed technology, these questions may finally be answered. Join us as we discuss NASA's latest discovery and the exciting possibilities for the future of space exploration. So, let's dive right in. To grasp the concept of light speed, it's essential to understand that light travels at a tremendous velocity of 671 million miles per hour, the fastest pace in the natural world. Electromagnetic waves, including light, radio waves, and gamma rays, are the only waves capable of reaching the speed of light in a vacuum. This is because they are massless particles. However, objects with mass like electrons and protons cannot attain the speed of light, as the energy needed to accelerate them would become infinite. The speed of light is a benchmark in physics used to measure other velocities in space. It's a fundamental constant that limits energy, matter, and information in the universe. The theory of relativity states that as an object approaches the speed of light, its mass increases, making it impossible for any object with mass to travel at light speed. NASA is undertaking a groundbreaking mission to push the boundaries of our solar system and discover the secrets of the universe. With cutting-edge spacecraft like the Parker Solar Probe and New Horizons, NASA is reaching speeds previously considered unattainable. Despite these remarkable velocities, they are still a long way from the speed of light. For example, Parker Solar Probe has reached a speed of 430,000 miles an hour, which is only a fraction of the speed of light at 0.05%. However, NASA isn't slowing down. They're developing innovative propulsion technologies like ion thrusters, solar sails, and even antimatter propulsion systems that will allow spacecraft to venture farther and faster than ever before. And while they may not be able to reach the speed of light, they're still making amazing progress. But what if there was a way to travel faster than light? NASA is exploring this possibility through the investigation of wormholes and other space-time shortcuts. These theories are still in their infancy, but the potential for faster-than-light travel is tantalizing. With NASA at the forefront of propulsion technology, who knows what the future holds? The possibility of traveling at speeds beyond our wildest dreams is closer than we think. The field of physics and space travel is always pushing the boundaries of what was previously thought to be impossible. In 2012, NASA physicist and advanced propulsion engineer Dr. Harold G. White proposed an idea that could potentially change the game. He suggested that instead of increasing an object's kinetic energy, warping space-time could be used to break the speed of light limit. Dr. White and his team have been working on creating a setup that can gently distort the course of a photon, changing its distance in a specific location and detecting the change with an interferometer. They hope to use this setup to determine if faster-than-light speeds, commonly known as warp drive, are possible in the future. Warp drive technology was popularized by the science fiction franchise Star Trek. However, Dr. White believes that the idea of warp drive is not as far-fetched as people think. He cites the expansion of space since the Big Bang, 13.7 billion years ago, and the existence of cosmology models that suggest early times in the universe had explosive inflation, when the early universe expanded exponentially fast for a fraction of a second. However, Dr. White and his team at NASA remain optimistic and determined in their quest to make warp drive a reality. They believe that their advancements in the field, combined with ongoing advancements in technology, will eventually lead to a breakthrough. The potential benefits of a functional warp drive are immense. For one, travel time between stars could be reduced from tens of thousands of years to just a few weeks or months, allowing for the exploration and colonization of new worlds in a much more efficient and feasible manner. In addition, the technology could have far-reaching implications for our understanding of the universe and our place in it. The possibility of faster-than-light travel would fundamentally alter our perception of space and time, and open up new avenues for scientific discovery and exploration. Einstein once declared that it was impossible to surpass the speed of light, setting a cosmic speed limit. However, Mexican physicist Miguel Alcubierre challenged this notion in 1994 with his idea of faster-than-light travel. He proposed a warp bubble propulsion system that expanded space on one side of a spacecraft and contracted it on the other, allowing it to travel without breaking the speed of light. Imagine it like standing on a flat escalator in an airport. The escalator moves faster than your walking speed, while the space around the ship moves faster than the ship's flight speed, maintaining its mass. As a result, we can travel faster than light in a space-time cloud without mass. Dr. Alcubierre wrote, "Space-time will push the spaceship away from Earth and draw it toward a faraway star." Although Alcubierre's paper was purely theoretical and faced significant obstacles, Dr. White and his team have been making progress in bringing this science fiction concept to reality. They have modified the fictional warp-traveling spacecraft and its propulsion system, including adding a ring around it, which they believe will significantly reduce energy requirements. Dr. White views his work on warp speed as a university scientific project aimed at proving the existence of a minuscule warp bubble in a laboratory setting. While they're not ready yet to send a spacecraft into warp, the team is optimistic about their progress and the future of interstellar travel. According to Steve Stitch, Associate Director of Engineering at Johnson Space Center, progress and innovation require a forward-thinking approach. He cites the example of how Captain Kirk's communicator in Star Trek was once a futuristic idea, but has now become a reality thanks to advancements in technology. While a warp drive has the potential to reduce travel time between stars from thousands of years to just a few months, we should probably not book reservations anytime soon, as it's still a long way off from becoming a reality. But as Stitch says, we must always keep pushing the boundaries of what's possible. Dr. White likens his experiments to the early stages of the Manhattan Project, which aimed to demonstrate a small-scale nuclear reaction as proof of concept. Similarly, he's working on demonstrating the physics and science behind the concept of a warp drive. Astrophysicist Neil deGrasse Tyson acknowledges that new discoveries and advancements in our understanding of the fabric of space and time are necessary for routine travel among the stars to become a reality. However, he emphasizes the importance of continuing to explore and think about these seemingly far-fetched ideas. Dr. Miguel Alcubierre, the theoretical physicist who first proposed the concept of a warp drive, has his own reservations about the practicality of the technology. He cites the vast amount of exotic matter required and raises the question of how to turn it on, as signals cannot reach the front of the warp bubble at speeds faster than light. Despite these challenges, Dr. White remains optimistic and appreciative of the perspectives and ideas of his colleagues. Whether they agree or not, the conversation and exploration of these concepts are crucial for the continued advancement of science and technology. Uncover the secrets of black holes and intergalactic travel by clicking on the video to your right. Thanks for watching. Until next time.